All right, guys, so continuing solving systems of non-linear, right there, non-linear equations, algebraically and graphically. So we are definitely talking about shapes like, I gotta grab my marker. All right, so we are talking about shapes like a line. We are talking about parabolas. And we are talking about specifically where they intersect. So there's a little confusion last class that solutions are when you cross the x-axis. That's true. That's a solution for a function when y is 0 or when f of x equals 0. So, however, when you have a system of more than one equation, we're looking for where they intersect each other. So we have done this graphically. We spent the last last day, or two actually, graphing systems. So now we are going to actually talk about how to solve them algebraically. So what we have here is you see the x squared and you see the y squared. When we see both x and y squared, we are looking at a circle. When you see the y and the x, but there's no square, that means we are talking about a line. So what we're looking at here is a line and a circle intersecting. And you guys already talked about how many possibilities there are for a line and circle to intersect. They could not intersect at all. You could have the line go through the circle. You could have the line just kind of skim the top of the circle. So you've got a bunch of different options here. And what our job is going to be is to figure out what situation do we actually have here. Since the x is isolated, this is a great setup for substitution. So I am going to use substitution just as we did when we were solving linear equation systems. But I'm going to now do the exact same method with a linear and a circle. Linear equation and a circle. Since the x is alone, anytime that you see x, I can replace x with 3y minus 5. So that means I can take this 3y minus 5 and I can substitute it into that x that's in the other equation. So I'm going to open up parentheses here. This is my x squared. This x squared right here, I'm just leaving parentheses here for that x to be substituted. Plus, and then I have the y squared, and I have the equals 25. So I have literally just copied this top equation, but I've left parentheses for me to replace the x. Since x is being replaced with 3y minus 5. So I'm going to actually put that in to the parentheses right here. Now this is why we spend the beginning of the year going over FOILing, multiplication, all of that fun stuff, factoring, because this is exactly where we're going to need it relatively quickly. I have a binomial being squared. So that means anytime that I have a binomial squared, I need to write it twice. So I'm looking at 3y minus 5 multiplied by 3y minus 5. And then I still have the plus y squared, and I still have the equals 25. I'm going to continue. I'm going to FOIL. So I'm going to take 3y times 3y. I'm going to get 9y squared. 3y times negative 5 gives me negative 15y. There we go. Negative 5 times 3y, again another negative 15y. And then negative 5 times negative 5 makes positive 25. I bring down this y squared. Okay, and then I bring down equals 25. All right, so now it's just basically, here we go, simplifying and then solving. So I have the 9y squared here with the y squared. So that gives me 10y squared. I also have negative 15y, and I have the negative 15y. So that's going to make negative 30y. And then I have this positive 25 I'll bring down, and then equals 25. When we are solving, this is going to be solving a quadratic. Since I'm solving a quadratic, we always want to solve set equal to 0. So I am going to subtract this 25, and I'm going to put it with its common term, which is 25, so that I can have 0 on the right-hand side of my equation. Now, these are the same numbers, so that means this 25 is also going to cancel out. So I'm just going to have 10y squared minus 30y. And to solve, I'm going to factor. Okay? So if I'm going to factor, I always look for a greatest common factor first. And in this case, 10 and y go into both of these terms. So I'm going to have a y left over and a minus 3. And the way that we can check that I did that correctly is if I try to distribute 10y times y gives me 10y squared. 10y times negative 3 gives me negative 30y. Once I factored, I'm going to set my factors equal to 0. So I'm going to take 10y and set 10y equal to 0. And then I'm also going to take y minus 3 and set it equal to 0 as well. If I divide by 10, I'm going to get y equals 0. And if I add 3, I'm going to get that y is equal to 3. Okay? Now, that means I'm getting two separate y's. I am getting 0 as one of my y's, and I'm going to get 3 as the other y. But it doesn't tell me what my x's are. So it looks like I'm going to have 2 points of intersection, which means it's probably going to look like this picture up here. It's going to cross twice. But I want to know what the x values are, because otherwise I don't really know where the points of intersection are. So since I know my y values, I can come back up to this equation right here, and I can substitute my y value and then get my x value. So if I'm going to do that, let's take 0 for example. I can put 0 into this y place. So that means I've got, I'll put my work down here, I have x is equal to 3 times 0. Okay, and then minus 5. Well, let's say 3 times 0 is 0, minus 5 is negative 5. So that means negative 5 is the corresponding x value for my y value of 0. I'm going to do the same thing with my other y value. X is equal to 3 multiplied by 3, because that's my other y value. I put it right in there, and then minus 5. So that is 3 times 3 is 9. 9 minus 5, that gives me 4. Okay, so that means that my circle and my line are supposed to intersect 2 times. Just to make sure, because remember this is only one method of solving, just to make sure I'm going to graph it as well to make sure I believe it. So x squared plus y squared equals 25. Let me go ahead and bring those equations onto the next page. All right, so here are my 2 equations. I'm going to go ahead, if you have graph paper, great. If not, just make yourself an x, y axis and make some tick marks. We know this is a circle because the x and the y are both squared. So for my circle, my center is the h and k value. I don't have any hk value. There's no minus something or plus the number with the x's and y's. So that means my center is at 0, 0, 0. And remember, this is your radius squared. So the square root of 25 is 5. So that means for my circle, okay, the center is at 0, 0. And my radius is the square root of 25. So that makes 5. Okay, so I'm going to take 5 up, 1, 2, 3, 4, 5 this way, 1, 2, 3, 4, 5 this way, 1, 2, 3, 4, 5 down, 1, 2, 3, 4, 5 that way. And I'm going to try my best with this smartboard marker. There we go, to make a pretty decent circle. Okay, There's my circle. And then this here is a line. And remember, when you're drafting lines, I have to get the y isolated. So I'm going to add 5 to the other side of my equal sign. I have 3y on the right-hand side. This says x plus 5, so I'm going to write it just as it says, x plus 5. I will divide by 3 because 3 is my coefficient. They are multiplying, so to get rid of the 3, 3 divided by 3 makes 1, so I have my y by itself. However, whatever I do to the right-hand side, I must also do to the left-hand side. So I'm going to write this. This is going to be x divided by 3, which is really 1/3 x plus 5/3. All right? And I'm going to graph that. So 5/3 is here. Here's 5/3. If you do 5 divided by 3, that gives you 1 and about 2/3 left over. So that is 1 and 2/3 is right in the middle, slightly above the middle, 2/3 of the way from the two edges of the box. My slope is 1 over 3, so I'm going to go up 1 over 1, 2, 3, or down 1 over 1, 2, 3. And then I'll do that again, down 1 over 1, 2, 3. And I have enough points now. Whoops, I didn't count 3 on the first one. Let's try that again. Let's see, this is good practice. There we go. Let's try that again. So down 1 over 1, 2, 3, and then down 1 over 1, 2, 3. Okay? And I will try to connect my line as straight as I can. All right? So my points are supposed to be, my solutions were supposed to be at -5, 0, and 4, 3. Let's see if we were right. So -5, 0, 1, 2, 3, 4, 5. That does look like we're pretty much close right there. And 4, 3. 1, 2, 3, 4. 1, 2, 3. 4, 3. All right, so I'm guessing my circle was drawn. If it was drawn a little bit further out, there we go. So they should actually be intersecting right there. Okay? So again, sometimes I can get it pretty accurate with a picture, but I can get it more accurate if I solve algebraically. So for the most part, we can solve with our picture, and sometimes we have to solve algebraically to get a little bit more correct. Okay? All right, so we're going to try one more together. And this one, I want you guys to see how it's set up. Notice how the 4x squared is lined up with another x squared. So these are common terms. And the y is lined up with another y, again a common term. These are both quadratics, okay? So we're looking at two quadratics, and we're trying to see when they might overlap each other. This is set up for elimination. If I have a +4 here on the first equation, I could multiply by a -4 in the second equation, and then I could add them together. So the very first equation I have not touched at all. So I'm going to keep it 4x squared plus 2y is equal to 3. I have not changed that one at all. But the second one I'm going to distribute the -4. So I have -4x squared. Oh boy, let's check that. Let's make that actually look like a 4. There we go. So -4x squared. And then -4y, and I've got -4 times 9, which is -36. Now I can add these together, and my 4x squared and -4x squared leave me with 0x squared. So there's 0. 2y minus 4y is -2y, and then the 3 minus 36 gives me -33. I can divide by -2, and I wind up with a y value of 16.5. Go ahead and pause here, take your 16.5, substitute it back into the y value in the first or the second equation, and see if you can solve for what the x value might be. In this problem, you get x squared equals negative 7.5, which would lead to an imaginary answer. Therefore, this system has no solution.